We've just been talking before about compass directions, for example, where that was in relation to degrees, compass, and bearings. So we're up to sort of compass directions. I wanted to show you, first of all, I want to backtrack a little bit and explain a little bit about how to use what we call a protractor. In other words, how to measure an angle. This could be used with compass directions as well, because maybe you have a map, and on the map you want to go a certain direction, so you know which way you want to point. It's really important to be able to measure angles. I'm going to just give you a quick example here of how to measure an angle. So maybe I'll just draw one. Okay, so I'll maybe say, what's the angle theta? In other words, the unknown angle. So maybe I'll just draw myself a straight line. It doesn't really matter how I do it. So maybe one here and maybe one like this. Maybe that's my question here. That there. Well, I need to define where my angle theta is. Maybe I draw it right here. Now we need to use what's called a protractor to do this. So I think I have a little virtual one here. Here it is. Hopefully it's not too big. Oops, it's a bit big. So what I can do here with this little protractor, if you watch what I'm doing, if you want to measure an angle, this protractor of course shows you angles from 0 all the way up to 180 degrees, and also goes 0 on this outside and goes all up to 180 degrees. In other words, you can start off an angle by measuring it on the right or on the left. So I'll show you how to use this. Of course, I can take it and I can rotate it if I want it, because maybe my angle didn't match up. But in this case, my angle matches up really nicely. In this case right here, let's say I want to measure an angle. I would put the center of my protractor on the center of my angle here. So I'm going to line it up, see this little X right here, with the center of the angle. And I need to have this baseline, so to speak, this little line right here lined up with a 0. So if I want to measure it like this, I go here, and if I want to go up this way, I'm going to use the inner numbers, because if I use the outer ones, no angle is called 180. Well, that doesn't make any sense. But if I go from 0 and I go all the way up, I can actually try to estimate it. Do you see how my angle right here seems to go a little bit past 50, but not quite 60? I mean, it depends on how accurate you really want to get. I mean, we can actually make this here a little bit smaller. I could actually zoom way in. I can do all sorts of crazy stuff here. But in this case here, I would have to estimate it at maybe 54 degrees, something like that. It would be pretty close to that at least. So it's an inexact science here, but we could theta is roughly, so I'll put an equal sign with a little dot. That often means, approximately 54 degrees. That's what we could say. But now if we assigned this, something like this right here with compass directions, we could also say what direction that was on a compass. Now this is 0 degrees from this 0 point here, so to speak, but 0 was to the right here, so that was 54 degrees. Try to think carefully then, how many degrees would it be if I moved this compass out of the way, this protractor, sorry. What would be the angle? Remember, if I want to know an angle right here with a compass direction, straight up has to be north. Let's assume that this straight up angle right here, this straight up value right here, let's assume that was, north. In other words, 0 degrees. If this is north or 0 degrees, we don't measure angles from here for compass directions. We measure them from north. In other words, I need to know this angle instead. Yeah, I need to know that one. If I know that one, I can say what's my compass direction. So in this case, I can use a little trick here. I know that this right here is 54 degrees. And so hopefully you can remember there's a little trick right here with right angles. What was the entire angle going from this straight value here to this straight value here, all the way across that, that entire angle is 90 degrees. So if this whole thing is 90, this little one right here is 54, and the question becomes, what's the angle missing? So of course you can do 90 minus 54, which in this case right here will be 36 degrees. Okay, so if I want to, what is the angle theta? Theta is indeed 54 degrees, but if I want a compass direction, okay, I could actually say this is, you have to head at 36 degrees. So see how it's a little bit different here? You can actually end up with different values here for the compass value. You could also say it's northeast, but it's not exactly northeast. If it was exactly northeast, this angle would have been 45 degrees. In other words, exactly halfway between north and east. So in this case, you're going, it's sort of north, east, but not exactly. It's not exactly northeast, is it? Okay, so that's how we can take a look at compass direction. And that brings us very well into what we call a bearing. Okay, so if we want to talk about a bearing, what we would do then is we would just add a number or a letter 0 in front of it. Oh, sorry, number 0 in front of it. So for example, if I want a bearing, these are all sort of together. If I want a bearing, then I would just add, it's a 3-digit number. So for example, this is especially used in navigation. So this here would be 0. That would be 0 degrees. Well, instead of calling it 0 degrees, we would actually say it's bearing 0, 0, 0. Or we could say it's 360 because you've gone all the way around. If you go around to the right like this bearing right here would be 0, 9, 0. Here we're just adding a 0 in front of it. This is 90 degrees. And if I went all the way around like this right here, around the half, this would be 180 bearing. And this one right here would be 270. And if I went all the way around like this right here, that would be 360, and so on. So a bearing is actually a very straightforward, very easy to understand. It's just related to north and east and south and west. And when I talk about north and east and south and west, what I mean by that is when I talked about a little compass, if you weren't sure what a compass actually is, it's a little device. It's a little thing that you can use to navigate. Maybe you have one when you go camping or something like that. You would maybe have a little rectangle like this right here. It has a circle like this, and it's going to have a little arrow that's going to point somewhere. And this arrow right here, that always points towards what we call north. So what happens is this little arrow right here, it's usually actually another piece like this, but the arrow is usually painted dark, so to speak. So the arrow points what we call north. And the reason is that this little arrow, it's a magnet. And magnets always like to point, well, I mean, magnets point somewhere. So the north on a compass will actually, tell you which way is magnetic north on the Earth. Of course, if you're in a physics class, you'll know that there's a little problem with that it turns out the north on the Earth is actually a magnetic south. But that's for a physics class. I don't want to confuse too much here. So the idea is the arrow here points north. So if you know that, then you can know which way to turn, so to speak, and you can navigate using this. I think it's actually really useful. So if someone is telling you where to go, they might tell you to head on a bearing or a heading, so to speak, of, let's say, 180. Then you know you're headed exactly south on a map. In other words, you're going to be going exactly down on your map, assuming your map is set up like this, where up is north and right is east. They usually are set up that way. Okay, so that's a really nice thing. I also want to show you just a quick little aside. What if you're actually in an airplane? This is actually something I thought was actually kind of neat, especially if you're flying in an airplane, about landing strips. Oh, I think so. Landing strips, in other words, runways for airplanes. This is actually a neat little extra thing, I think. So if you're in an airplane, I remember I thought this was really, really neat when I was first learning how to fly, that your landing strips are actually named, so to speak, according to compass bearings. So let's say you're flying in your airplane, and I'm going to try to just give you a view of what you see in your airplane. This is your little, cockpit, and maybe you have your little control wheel here. So this is you kind of trying to fly your plane, and this is kind of the inside of your plane here. This is your, the bubble where you're looking. So you've got, your hands here. This is me, holding on with my hands. This is me here. Okay, so I'm looking. This is what I see here in front of me, so to speak. If I'm trying to line up with a runway, the runway is going to look. Because of perspective here, it's going to look. It's a straight line, so to speak. It's a big, long, straight thing. But as you're coming towards it, this number right here, this is going to look a little bit bigger than the back side of it right here. That's just because, of course, on a map, if you look straight up, it would look like this, a nice rectangle. When you're actually flying towards it in real life, you'll actually see something that looks a little bit more like, it looks a little bit like a strange sort of shape like this right here, because, this part right here is closer than that part. And the cool part is when you're flying towards a runway, maybe the runway says 09, for example. They paint this in huge, ridiculously sized letters or numbers here, for example. Just to show you how they name them then, they would actually name them, if it was 09, that actually tells you which way you're pointed. In other words, if you're looking at a map and you want to land on a runway that's actually facing, oops, actually not like this, a runway that's actually facing this way, like this right here. If you're facing to the right, it'll be actually runway 09.